Namaste everyone, myself Rajkumar Kanojia. Today through this video I will try to make you understand area of circle and some basics of areas related to circles, chapter number 12, 10th CBSE. We all know that area of circle is pi r square, but most of us we don't know how we got this pi r square. Through this video I will try to make you understand that how we got this pi r square, right? So let's say we have a circle, right, whose radius is r, right, and let's say we have one cutout of this circle, right, and this circle, what I'm trying to say, this circle we will try to cut into 8 or 16 equal pieces. I repeat, cut into 8 or 16 pieces, and these pieces looks like a triangle, and these triangles we will try to arrange. Let's see, after arranging these triangles or sectors, we can say what we get. Let's say this is the first piece which I'm drawing in front of you. This is the first piece, this one is second piece, this one is third piece, this is fourth one, this is fifth piece, this is sixth piece, this is seventh piece, and this is eighth piece. We all know that circumference of circle is nothing but 2 pi r, right? And this circumference, if you see, if I put numbering from here, so this circumference is divided into two parts. First part is this and second part is this. That means this 2 pi r is further splitted into pi r and pi r, which means this portion is pi r. When I'm saying this portion means this length is pi r, this length is pi r. This figure we are getting somewhat like parallelogram, and we all know for any parallelogram area is what? Area is nothing but base into height. In this case, when you will see, this base is what? Pi r, right? And from here to here we know that this is radius r. So therefore from here to here, if I draw one perpendicular, that means this will be nothing but this will be again r. That means height is also r. So what we are getting? Pi r square. But from where we have obtained this parallelogram is exactly obtained from this circle. That means these two areas must be same. Therefore this area of parallelogram is nothing but area of circle. I can show you practically how it looks. I have the same circle, I have cut it into 8 pieces, and when I place this to form parallelogram, I have just stapled on a strip. So where you can say this is first, second, third, fourth, fifth, sixth, seventh, eighth. We have 8 sectors, right? So where this plus this forms what? Circumference. Therefore this is just a pi r, this is pi r, this portion is r. So that means the area of this parallelogram is what? Area of this parallelogram is base, that is pi r, into height, that is r. So what we get? Pi r square. So friends, I hope you have understood that how we can get area of circle using area of parallelogram concept. I hope this is clear and you have understood this area of circle formula through this activity, right? Further, as I said, that this is also basics of areas related to circles, which you have in 10 CBSE chapter number 12. So I will just try to make you understand what different parts we have in areas related to circle. So friends, this is circle. I'm just trying to make you understand that when area is enclosed by two radius and the arc, this portion is arc, this part is known as sector. This part is known as sector, right? So in this case, sector, the sector, from where you are trying to get this is a part of circle. We can say a part of circle. And this part of circle, from where how much you are cutting or eliminating from this portion, this is theta, right? So this portion, this ratio, when I talk about, I'll take some few small examples. This is, I'm trying to make you this is semicircle. So its area will be what? Half pi r square. You may ask like how we are getting half from here, because this half is nothing but the angle at the center. That means this, what is this angle actually? This angle is 180. Out of total is what? 360. From where? From circle. That means pi r square. So when we cancel this, we get half pi r square. Similarly, if I take an example of quadrant, right? This is quadrant. What is the area of quadrant? 1 upon 4 pi r square, as this is 1/4 of area of circle. How we get this 1 upon 4? To make you understand, this 1 upon 4 is nothing but this is 90 upon 360 from the circle, so pi r square. Hope this is clear. Similarly, when you have any general sector, right, we don't know in this case angle, and this angle is denoted by theta. This angle is denoted by theta. This is also sector, we can say. This is also a sector which is spatial sector, which is the quadrant. This is also a spatial sector, which is a semicircle. So when it comes to area of sector formula, so area of sector formula, what is important? Central angle. In these three cases, if you can see, 180 upon 360, 90 upon 360. When we don't know angle, that means central angle is theta upon 360. From where you are getting? Circle, pi r square. That means this area of sector, this portion is, area of sector is nothing but theta upon 360 into pi r square. Hope it is clear, right? So this was the we try to get area of sector, right, through this. Right now I'm trying to make you understand length of arc, length of an arc. This length of an arc means I'm talking about this portion. This you can see in this figure. This length of arc is nothing but a part of circumference. A part of circumference. Let's take general formula again, same as like this. When you have this portion, and we know that circumference is what, friends? Circumference is nothing but it is 2 pi r. Circumference is nothing but it is what? 2 pi r. If I take the example of semicircle in this case for length of arc, so semicircle's circumference, I'm talking about circumference, I'm not talking about perimeter. So when I say circumference, that means only this portion from here to here. So in this case, this is nothing but half into 2 pi r. That means you may ask from where we are getting this half. Same rule, right? As this is spatial sector, spatial sector is semicircle in this case, as angle is 180. That means 180 upon 360 into 2 pi r, that is circumference C, right? Similarly, if I take the example of quadrant, right? So in this case, the circumference will be 1/4 of C. So you may ask from where we are getting 1/4. So that 1/4 is nothing but central angle 90 upon 360 into circumference C. Now if I talk about length of arc, let's say this portion, right? And when we talk about this portion, that means this portion, for this portion we need this central angle which is unknown. So let's say this angle is theta. So in this case, length of an arc is equals to central angle theta upon 360 into its circumference. What is circumference, friends? 2 pi r. So this is what length of an arc. I hope you have understood length of arc as well. Now I'll try to give final relation between area of sector and length of an arc. So friends, here I'm talking about relation between area of sector and length of an arc. What we know, friends? So area of sector is what? Area of sector formula, what we know? We know that area of sector is theta upon 360 into pi r square, which can be expressed as theta upon 360 into, now see this step very carefully, then only you will understand, otherwise further you may get confused. So I am writing this pi r into r. Try to understand what I am trying to do. This pi r square, I have written pi r into r. Here what I am trying to do, I am giving 2, means I am multiplying by 2. I am taking 2, that means I am dividing by 2. Now when you observe this step, we get this as 2 pi r into r by 2. That means if we cancel 2 again, so we get it again pi r square, which is exactly same as this. This is what we call it as manipulation mathematics. So that means this becomes this. If you observe this formula and if you observe this formula, length of arc, so what you see that this and this both are exactly same. That means this is nothing but this is length of r upon 2. That means what is the relation between A and L? A is area of sector, L is length of arc. So the relation is A is equals to LR by 2. This formula when you can apply when area is required and length of arc and the radius is given, or if area of sector and radius is known, you can use this to get L. So in this case L will become what? That is 2A upon R. That 2 gets multiplied with A, so 2A, R will come down, so that is 2A upon R. I hope you have understood. This is very important for chapter number 12, areas related to circle. I repeat, so area of sector is what we have got? Theta upon 360 into pi r square, and length of an arc is what? Theta upon 360 into 2 pi r. Relation between A and L is what? A is equals to LR by 2. These derivations are in front of you. You may pause a video and you can make a note of these things. You can write these formulas. So we have learned today area of circle through an activity, area of sector, this is the derivation, and length of arc, again you can say this is a derivation, and we have understood the relation between area of sector and length of arc. I hope you have understood this properly. You may make a note of these things, right? Hope you will share with your friends and you have liked this video. Thank you so much. In the next video I'll be explaining about the area of segment. Thank you so much. Thank you everyone.